Good morning, Dr. Yeo. We are from Group 5. Our assignment title is Power Transmission System of Baggage Conveyor System in KIA. So I will introduce the conveyor system and objective of the assignment. A conveyor system consists several mechanical parts such as drive drum, end drum, fed belt, and roller, so that it can transfer an object from one point to another point. A fed belt conveyor is chosen as the title of our assignment. So the objective of our assignment is build a power transmission system to transmit power from induction motor to conveyor system. Then the basic mechanical element contain belt drive, chain drive, and gear reducer. Next, I will present about the design requirement of this system. The total length of conveyor system is 30 meter and weight is 0.6 meter. The diameter of drive and end drum both are 18 cm. The speed of fed belt is required to run at 0.3 to 0.5 meter per second. This conveyor system requires power of 5 kilowatt to 8 kilowatt. A 3-phase 4-pole 8 horsepower and 2,900 RPM of the AC induction motor is required for this conveyor system. A PTS is required to deliver high torque power to conveyor. So this is the construction design of our PTS system. As we can see, the induction motor and gear reducer is connected by a belt drive. The gear reducer is to reduce speed and generate high torque power to drive drum through the chain drive, so that the baggage on the fed belt can be transferred smoothly from drive drum to end drum. Thank you.
I am Tiong in Sheng. I will present calculation and designing. So for this part, it divided into 4 parts: belt drive, gear reducer, chain drive, and shaft and bearings. The duty of the belt drive is to transmit power from motor to gear reducer. It is suitable to transmit high-speed power from motor. So how we design? First, we find a suitable belt based on design power and RPM. Next, we will find standard diameter for driving and driver shift. Third, we will find standard length of belt, and lastly, we will calculate how many belt is required. The duty of the gear reducer is to reduce speed and increase torque. So three pairs of gear is used to avoid using large diameter gear, as shown in picture below. So first we will find geometric pitch and diameter of pinion, and we will calculate number of teeth for pinion. Lastly, we will calculate centing for gear as well. In the design, diameter pitch is getting lower and lower, but face width is getting higher and higher from gear 1 to gear 6 due to the torque is increasing. So when we use the gear, we need to consider backout ratio of the gear and contact ratio of the gear. Both of them minimum requirement is 1.2. Third, the duty of the chain drive is transmit power from gear reducer to conveyor. This is suitable to transmit high torque power to conveyor. Lastly, shaft design. So totally we have 6 shafts in this PTS system. Shaft 1 is connected to motor, shaft 2 is connected to conveyor, and shaft A, B, C, D is the shaft from gearbox. The elements we install into the shaft are bearing, shift, gear, sprocket. For the bearing, we use interference fit or force fit. So for the rest, we use current fit. For the bearing, tensile stress checking is necessary to make sure that the bearing could endure the tensile stress from shaft. For the current fit, returning ring and key seat is required to fix them on the shaft. When we design the shaft, normally we will face 2 scenarios. Number 1, when the diameter of shaft is bigger than inner diameter of corresponding bearing, then we won't use that corresponding bearing, but choose a bigger one. Second scenario is when inner diameter of bearing is bigger than diameter of shaft. In this case, we will make the diameter of shaft bigger or redesign the shaft by adjusting the length of the shaft to change the bending moment to subsequently affect the minimum diameter of shaft. Thank you.
Hey, my name is Chong, the next presenter, and I'm going to talk about the specifications of the power transmission system. There are 3 parts, that is the belt drive, gear reducer, and chain drive. First is the belt drive. It's a design power of 11.2 horsepower, so 2 belts were used, and each belt is a 3V belt. There are two shifts, the driver and driven shifts, and both have an outer diameter of 134.6 millimeters and 203.2 millimeters respectively. The center distance between both shifts is 204.38 millimeters. The belt drive has an input speed of 203.69 radian per second and output speed of 203.2 radian per second. The speed ratio is 1.51. Here's the technical drawing of the belt drive as well as images of the 3V belt and the shift with two groups. The second part is the gear reducer, and it has three pairs of gears. The diameter pitch of the three pairs of gears are 12, 8, and 6 respectively. The input speed is 201.2 radian per second, and the output speed is 7.78 radian per second. The train value of the reducer is 25.86. This image is the gear reducer in isometric view, and followed by that is the picture of the spur gear. Last part is the chain drive. It has a design power of 11.2 horsepower. As such, number 80 chain with a pitch of 25.4 millimeter is used. There are two sprockets, the driver and driven sprocket, and both are number 80 sprocket with a single strand. For the driver sprocket, it has a number of teeth of 40 and pitch diameter of 203.74 millimeters. As for the driven sprocket, it has a number of teeth of 60 and pitch diameter of 485.33 millimeters. The center distance between both sprockets is 1012.77 millimeters. The input speed is 7.78 radian per second, whereas the output speed is 5.192 radian per second. The speed ratio is 1.5. Here's the technical drawing of the chain drive, and after that, shows the images of the number 80 chain and the number 80 sprocket with a single strand. Thank you.
Good evening, Dr. Yeo. My name is Hee Jee Yao. Now we are going to discuss the gap of knowledge that we face throughout this assignment. First will be lack of knowledge and understanding on the application of shear stress formula to calculate the desired size factor of the shaft. Next is a lack of information on the specific dimension constraint while designing a legitimate retaining ring, key seat, and coupling. Next is regarding the bearing housing, as we don't know the proper way of installing the bearing into the cast practically, and we shall just assume these bearings are supported by extruded casting instead of mounted into the wall. Furthermore, we do not have enough information to operate the simulation to conduct stress concentration analysis, as more variables are taken into the consideration practically, and we could only design based on partial essential requirement. Next, I'm going to present the strength of our design. Our model is extra stable and high performing, as twice of the needed torque is supplied to avoid overloading, which could slow down the conveyor. Moreover, our design is absolutely reliable, as it meets the minimum requirement and able to achieve all the preferred reading in datasheets. Hence, we can assure that there will not cause any undesirable failure which caused by the improper design. Besides that, the power transmission system is designed as expo to improve the flexibility for the technical maintenance purposes and reduce the risk for technician getting injured. Lastly, it is a practical design model, as all the elements in the power transmission system are extracted from a reliable catalog. Next, we will be discussing regarding the weaknesses of our model. It is very costly due to several reasons. For example, it requires expensive latching manufacturing process, a more expensive type of ball bearing for higher loading consideration. Chain drive is selected instead of belt drive, which lead to a higher cost, and the cost for lubrication is also essential for chain drive maintenance as well. Besides that, the large dimension of some element in the power transmission system, which turn out a lot of unwanted empty space. Finally, we will discuss about the improvement that can be done on our model. A lower RPM of induction motor should be chosen to reduce the elements that in our gearbox to convert to a desired torque. Besides that, chain drive is relatively much larger than belt drive in our design. A higher speed ratio should be implemented in belt drive to enlarge overall size of it, and lower speed ratio should be implemented in the chain drive to reduce the overall size of it to achieve a more balanced drive system. Thank you.
I am the last presenter of our group. My name is Tai Zhen Hang. Here I will give a brief image of our conveyor system, including some of the main components inside the PDS system, which will be placed inside KLIA for baggage transport purpose. The conveyor is 30 meter long and has a useful width of 550 millimeter. The whole PDS system is at one end terminal of the conveyor. There is a small room to protect the PDS system. The door is labeled with some warning label to alert public not to open it. After we open the door, we can see our main components of the PTS. First of all, we have a 3-phase AC induction motor beside the door which can produce 8 horsepower and runs at 2,900 RPM. The second power transmission component take place is the belt drive, which reduced the angular speed to 201.2 radian per second at 41.5 Nm torque. The driven shaft then connects to the gearbox. Inside the gearbox, there are 4 shafts and 6 spur gears. The final output of the gearbox gives a torque of 1072 Nm. The last power transmission component is a chain drive. The gearbox connects the driver's sprocket, and the driven sprocket is connected to the drive bump of the conveyor with a coupling which shown in red color. It will drive the conveyor at constant speeds of 0.4 meter per second to transport the baggage. As a conclusion, on behalf of all of my group members, throughout this assignment, we are not only familiarize ourselves to the application of PDS system, but also the technical calculation involved to design a safe and practical power transmission system. Although there are some knowledge gap and ambitious assumptions have been made, which completing the calculation, we take this challenging process as a good learning experience. Thank you.